All right, so we started on example 7, and maybe we should just go over what we already know about polynomials. All right, we know standard form means they are set in descending order and equal to 0, right? The terms is just the number of, it could be letters, it could be numbers, it could be both of them together, but they're separated by either an addition sign or a subtraction sign. And you've combined all your like terms, right? I guess that's why we call them like terms. Your leading term, when you put it in standard form, it's the one with the biggest exponent. That's always going to be in the front. Okay. This leading term is 5x squared. Your coefficients are the numbers that are in front of the letters. So the coefficient of negative 7x squared is negative 7. The coefficient of negative 3, x to the third is negative 3, right? The constant is any number that does not have a variable. And the reason we call it a constant is that no matter what variable you put in, that number is constantly itself, right? The degree of this polynomial is a degree 4 because your degree is just the greatest degree of the degree of the biggest term or the leading term. So the greatest degree in your polynomial is the degree of your polynomial. Good. When you're looking at a graph, it should be a smooth graph and it should not have any gaps or holes in it. Good. We talked about how a polynomial function cannot have a fraction in the exponent. It has to be a whole number. It has to be a whole number that is greater than or equal to 0. And you can't have a variable in the bottom of your fraction, right? So these are just the rules of polynomial functions. What else? We talked about whether graphs were smooth and continuous. And then we talked about the power function. The power function is the leading term, right? This isn't exactly the paper we use, sorry. But 5x to the 5th minus x squared plus 2, your leading term is going to be 5x cubed to the 5th, right? 5x to the 5th looks almost the same as 5x to the 5th minus x squared plus 2. It's your leading term. If it's in factored form, what you do to get your leading term of 2x to the 4th is you multiply any number that's out in front, and then the beginning or the variable part of each of your factors. So 2 times x to the 3rd times x is going to give you 2x to the 4th. X times x to the 4th, because it's x squared raised to the 2nd power. So x times x to the 4th times x is going to give you x to the 6th. Good. So that would be a degree 6 polynomial. That's a degree 4 polynomial. That's a degree 5 polynomial, right? We talked about real zeros, and the way we see most real zeros is put in factored form. So we decided that the real zeros of x minus 3 squared times x plus 4 are 3 and negative 4, because your real zero in factored form is going to be x minus that r, okay? So x minus positive 3 and x minus a negative 4 would give us these two factors, right? The newest information, so what I was explaining right as class ended, was that to find the x-intercept, you need to multiply your constants, okay? So we find you find the degree or the leading term by multiplying the first numbers, right? X squared times x, so that would be a degree 3 polynomial. And if you want to find the y-intercept, you're going to multiply the constants. Okay, I'll write that down because that's what we did. We multiplied negative 3 squared and 4. Notice that we didn't multiply the actual 0, right? Because the 0 is positive 3 and negative 4. So you are just taking the equation. You're not taking the real zeros. So negative 3 squared times 4. We multiplied the constants to find the y-intercept. Okay, our constants were negative 3 squared, which becomes 9, and 4. So negative 3 squared times 4 is 9 times 4, which is 36. If you're going to change a y-intercept to an ordered pair, right, it's going to be 0 on the x-axis 36 on the y-axis. The y-intercept is 0, 36. All right. Graph by locating other points if necessary, and use the x-intercepts to find the interval on which the graph is positive and the interval on which the graph is negative. This is from our previous units, right? Okay, so real zeros and state their multiplicity. Let's think about this. Okay, the real zero is 3, right? What does that mean? That means it's going to cross. When the real zero is a positive 3, that means it's going to cross the x-axis at positive 3, 0, right? And it was a multiplicity of 2. Remember, a multiplicity of 2 is an even multiplicity, so it's going to touch the x-axis, okay? An odd multiplicity is going to, what was the other one? Cross over it or pass through. Okay, so because the -3 is squared, because that factor is squared, it's only going to touch the x-axis and come back. So it's either going to go down and come up or up and come down, whereas cross means it's going to go through. So at 3, 0, it's going to touch the x-axis. This one was -4. That means that the point is -4, 0, and it's going to, because it has a multiplicity of 1, that's an odd multiplicity, so it's going to cross the x-axis. You are welcome to just use a graphing utility if you would like. Okay, so what do we know about this graph? Let's see if we can graph it without using any extra points, without finding any other points, okay? Because we do know something about it. Sorry. We know. I have this paper over here. All right. At 3, 0, it's going to touch the x-axis. At -4, 0, it's going to cross the x-axis. Right? Now, the only place it crosses the y-axis is at 0, 36. So it's not going to be as, here we're counting one at a time. Here I'll count by 5. So this is 5, 10. So it's going to cross the y-axis way up here. That means that it's positive between this point and this point, right? So it must touch like that. So that's really all the information you need. You know, it's going to cross here. It's going to cross here. And it's going to come down and touch and then start going back up forever here. Okay. So, and then it says use the x-intercepts to find the intervals on which the graph is positive and the intervals on which the graph is negative. Remember, positive just means it's above the x-axis, okay? Negative means the graph is below. Good, and I guess I didn't include an arrow on this side. Good, and you're just thinking about it in terms of the interval on the x-axis. All right, so it is positive. Ooh, all right, on this graph, right? F of x, we can say is positive, right? Or we can say is greater than 0, okay? Where is it greater than 0? From right here, which was -4, right? It's positive from -4 all the way to 3, right? -4 to 3. It's not positive at 3 because at 3 it's equal to 0. And so it's going to be positive again at 3 to infinity. There are no brackets, there's only parentheses because at -4, it's not above 0, it's at 0. At 3, it's not above 0, it's at 0. At 3, it's not above 0, it's at 0. So we can't include -4 and 3, but after them and before them and then after them again. Okay, so that was positive. And then where is it negative? The way we would write that is f of x is less than 0, right? Where is it less than 0? Everywhere before -4. So if it's before -4, it's negative infinity, right? From negative infinity to -4, it's above the x-axis. And you could even write, so that's down here, you could even write that f of x is equal to 0 at the points -4 and 3. Maybe we'll say x equals -4, x equals 3. Good. All right. So all they give you is this. You don't use a graph, you don't do anything, and you don't use a graphing utility or anything. You can still figure out what that looks like. That's cool, huh? All right. Number 8, example number 8 is talking about turning points. A turning point is the point where the graph changes direction. It goes from concave up to concave down. The max number of turning points in a graph is 1 less than the degree of the polynomial. So let's look at the one we just made, right? We are going infinity in this direction. We go up 1, 2, right? There were 2 turning points on this graph. Do we agree? And there were 2 turning points on the graph, and the graph is f of x equals x minus 3 squared times x plus 4. Yeah? So what this says is the maximum number of turning points on a graph is 1 less than the degree of the polynomial. What is the degree of this polynomial? Remember, you can multiply it all out, put it in standard form, find the biggest term, right? The biggest exponent, or you can, to find the degree, you can multiply your variables and anything that's out in front right here, okay? So to find your first term, we're gonna think about if I FOILed all 3 of these, what would I have as my first term? I would have this times this, right? So let's just take that part. X squared times x, so that's going to be x to the 3rd. It's a degree 3 polynomial. Let's come back here. A degree 3 polynomial has 2 terms. Degree 3, 2 turning points. So what this page says is the points where the graph changes between concave up and concave down. Concave up means like this. Concave down means like that. The max number is 1 less than the degree of the polynomial. This is a degree 3 polynomial. It has 2 turning points. So the number of turning points is this number minus 1. That's all they're saying, okay? So for example 8, it says the number of turning points in x plus 5 times quantity x minus 2 squared times quantity x minus 4 times x plus 1. Good. So what is our degree here? The degree is we're just going to take our first terms, x times x squared times x times x. If I FOILed all 5 of these out, I would have x times x squared times x times x. Now I'm just adding, right? Because that's the rule for multiplying exponents. Keep the base, add the exponents. 1 plus 2 plus 1 plus 1 is 5. So our turning points is, let's see, less than, right? It could be the max number. So it could be less than or equal to 4. End behavior. So the end behavior of the graph of your function is the same as the graph of the power function. So way back at the beginning on like the third slide, we said that when you find the power function, your graph will resemble that power function. If it's x to the third, it's going to look like all other graphs with x to the third, right? So that's because it's going to go, once it does its thing in the middle, it's going to go forever. It's going to follow an arrow. You're going to be able to draw an arrow because it's going to do the same thing forever. Okay. It has some action in the middle, and then it's going to do the same thing forever. It's going to, both sides are going to go up, or both sides are going to go down, or one side's going to go down, the other side's going to come up, or one side's going to come up, the other side's going to go down. Those are your options. Okay. The way you decide that is you look at your variable n, and you look at, is this a positive x or a negative x? Or is there a positive term in front of the x or a negative number in front of the x? Okay. We call it AXN, but I think it's easier to just say if this is positive. Okay. So if A, which is in front of x, if A is positive, the graph opens up on the right. Okay. Up on the right. That means my x is positive. My x is a positive number. So it might be a 3x, it might be a 2x, it's not going to be a negative x, okay? If A is negative, the graph opens down on the right, okay? So that means that this is a negative x, this is a negative x. If your leading power, if your power function is a negative number, your graph is going to go down when you're reading it like a book, right? If your if your power function is positive, it's going to eventually go up forever. Good. That's what it means by if A is positive, if A is negative. You don't even need a number, you just need a sign. It's a positive x, it's going to go up. If it's a negative x, it's going to go down. Okay. The second part is, what is the variable? Okay. So this is a positive x, right, to the even. If it's even, the graph will go in the same direction. Positive x to the 2, positive x to the 4, positive x to the 6, positive x to the 8th power. Okay? It's going to look like that. Here, let's just do negative x to the 2nd, negative x to the 4th, negative x to the 6th, negative x to the 8th. Okay? Because they're both going down when it's even. They're both going up if it's even. They're going the same direction. Whether it's going up or down depends on the power. But the exponents are always even. Right? Here again, we have a positive x, but if n is odd, they go in opposite directions. So here is positive x to the 1st, positive x to the 3rd, etc. Right? You don't have to write all of these. Okay. It's a positive x because it's going up to the right, and it's an odd because it's not both going up to the right. Last one, negative x to an odd number. Okay, so if that number is odd, it's going to change directions. If it's even, the directions are going to stay the same. If it's positive, it's going to open up. If it's negative, it's going to open down. That's what end behavior, that's what you should know about end behavior. And if this part is very easy for you to understand, that is fine. More efficient than what I did, right? So let's apply this. Which graph in the figure could be the graph of f of x equals x to the fifth plus ax to the third plus bx squared minus 2x plus 3. So because we have that a and that b, we can't technically just put it into Desmos, right? Desmos doesn't like us to have a's and b's. But you know enough, right? You know enough, you know how to find from just this, you can find the power symbol, right? It's x to the fifth. So we know if it's a negative opening down or a positive opening up, we know that an odd exponent, we know that an odd exponent is going to go look like that, right? We know that a positive variable is going to look like that, right? So it's going to look something like this because of our power function. We know that 3 gives us what? The constant gives us our y-intercept, right? That means our y-intercept is going to be at 0, 3. Our x to the fifth, it's a positive, so it's going to be opening up, and it's an odd, 5 is an odd number, so it's going to look like this. It's going to go down to the left, up to the right, right? Down to the left, up to the right. It's going to cross at 3. And what did we just learn about power? Or sorry, yeah, based on the degree, we know how many turns, right? The max turning points is going to be less than or equal to 4, right? So you take the degree of that whole polynomial, subtract 1, and we say this has less than 4, or sorry, less than 5 turning points. Sound good? That looks like enough information to eliminate 3 of these. All right, so we have, well, let's just, the easiest part is a positive 3, right? Does it cross at positive 3? It does not. Does it cross a positive 3? Possibly. Does it cross at positive 3? Possibly. Does it cross at positive 3? Possibly. All right. It needs to be going down to the left and up to the right. Okay. Okay. This is not going down to the left and up to the right, so we're going to eliminate that one as well. Now we need to count the number of turning points, right? So a turning point is, you can just count the top or the bottom of the hill or valley. We got one point where it turns, another point where it changes direction again, changes direction again. Here we've got 4 turning points. Here we have 1, 2, 3. Well, we have way more than 4, right? Too many turning points. So I'm going to say that this is the only one that could be the graph of f of x equals x to the fifth plus ax to the third plus bx squared minus 2x plus 3. Good? All right. Almost done. Find a polynomial function whose graph is shown with the smallest degree possible. So now you know enough to even create your own equation out of a graph. Are you ready? Okay, let's start with this, right? The y-intercept. What is that point? 1, 2, 3, 4, 5. So if that's 5 and that's 5, we're just counting by ones. 1, 2, 3, 4. So that's the point 0, 4. So we know our constant is 4, right? Okay, let's look at our x-intercepts, right? We have one here, we have one here, and we have one here. That x-intercept is going to be at negative 1, 0, right? That x-intercept is going to be at positive 1, 0. And I think that other one's just at 2, 0, right? Let's talk about what the graph is doing there, right? Here, it's touching. Touching means that it's going to be an even exponent or an even multiplicity. Because if we think back all the way to Monday, if it's an even multiplicity, it touches and comes up or touches and goes back down, okay? If it crosses all the way through, it's an odd multiplicity. And you can remember that if it's ever an emergency situation by thinking about what, if x is raised to the first power, it's just a line, right? If x is raised to a third power, an odd power, it's a curved line, but there's never a place, there's not really as obvious a place for it to go down and come back up like a true parabola, okay? So even looks more like x squared, odd looks more like x or x to the third crossing through, if you need to remember that, okay? So let's look at, so we found all of our intercepts, right? Now, we can say, good, that the real zero of -1, 0 is -1, right? The real zero of 1, 0 is 1, and the real zero of 2, 0 is 2. So the real zero is where they cross the x-axis, okay? When we are trying to put it into the function, what do we do with the real zero? The real zero is combined with x, but it's negative, it's combined with x, right? That's how we would write it as one of the factors of this polynomial. So if my real zero is -1, that means I take this in my factored form and say x minus -1 is one of my factors of this polynomial. Based on it touching here, I can find the factors, okay? If it crosses here, I know that's another real zero, so that's x minus 1. It crosses here, so I can also say another one of my factors is x minus a positive 2. Good. Simplify that to x plus 1, x minus 1, and x minus 2. Oh, I got too wishful thinking about my voice not failing me. All right, let's talk about what the even and odd multiplicity means. Even multiplicity means just what we did over here. These are even multiplicities. These are odd multiplicities. So we're raising the whole factor to an even number, okay? But it says smallest degree possible. So what's our smallest even, smallest degree possible? What's our smallest even exponent? It's a 2. What's our smallest odd exponent? It's a 1. So we're trying to make the smallest degree possible. So we're going to call this exponent, we're going to call this multiplicity 2 because it's the smallest even number. This multiplicity 1 because it's the smallest odd number. This multiplicity is also 1. All right. So we have f of x f of x equals x plus 1 squared times x minus 1 times x minus 2, right? If I multiply, so we know that that covers that, that covers that. Okay, that covers that touching the x-axis here. That covers that touching the crossing the x-axis here. That covers that crossing the x-axis here. How do we make sure it goes all the way up to 0, 4? If we find what is our constant, right? Or what is our x-axis? Sorry, y-axis here. We have 1, times -1 times -2, right? -2 times -1 times 1 only equals 2. So what you want to do is stretch this out. Remember last unit when we added vertical stretches into our graph? You can put a 2 in front of all of this, then everything gets multiplied by 2. And our final answer is f of x equals 2 times x plus 1 squared times x minus 1 times x minus 2. All right, that is the end of 5.1. We're going to go on to 5.2, but like I mentioned already, 5.2 is just practicing finding the y-intercept, finding the real zeros, determining the end behavior, and determining the number of turning points as though you were going to graph everything by hand, okay? So let's just see how far we get, right? Example 1 is the graph of f of x equals 3x plus 1 times x minus 2 squared, right? And what did I say we want to know? We want to know the leading term. Let's start there. Oh no, please go. So 3x times x squared, right? Because that is distributed to the x. So 3x times x squared is 3x cubed, right? That's our leading term. So what we did is we took the leading term of each factor, 3x and x, and we included the multiplicity, which is also known as the exponent, right, of each factor, and multiplied them together. So as I was talking about the end of 5.1, I was alternately calling it an exponent and a multiplicity, right? Because those are basically the same thing. It's either the exponent of the whole factor or the multiplicity of it, right? So if I had FOILed out 3x plus 1 times x minus 2 times x minus 2, I would have ended up with 3x cubed as my leading term, right? Let's look at this. My leading term, remember this guy, okay? The end behavior information comes from the leading term. Okay, that is fine. Thank you for telling me. So this information gives us what we need to know, or our leading term gives us this information. So a 3 is going to be a positive x, right? So it's going to be positive to the right because it's a positive 3. And then the x is cubed, so that's an odd x. So our graph is going to look like this. Because our leading term is 3x cubed, our graph is going to begin on the left, it's going to be going down, and on the right, it's going to be going up, okay? Because the 3 is positive, it ends going up to the right, and because this 3 is odd, they're going to go in opposite directions, okay? So this 3 means they're going in opposite directions. This 3 means it's going up. All right, let's decide how many turning points it has. Yeah, the leading term is 3x cubed. The number of turning points is your total degrees minus 1. So that's 2, and it could be, remember, even less than that. So it's less than or equal to 2. Now let's find our real zeros. Our real zeros are our x-intercepts. Those are interchangeable, okay? The real zeros are the x-intercepts, and in factored form, it looks like x minus r. Okay, so I have 3x plus 1, and I have x minus 2 squared. We say it's x minus r, but what it really is, what it really is setting this equal to 0 and finding it. It just happens to be that if this is x as alone minus a whole number, the opposite of that, or the positive of that negative whole number, is going to be what x equals, right? But if it's not as simple as that, you just set it equal to 0, okay? Do not hesitate to set it equal to 0. So we have 3x plus 1 is 0. I'll subtract 1 from both sides. I'll get 3x equals negative 1. Then I'll divide it by 3 and I'll get x is negative 1/3. So the real 0 here for all of this is negative 1/3. What's the multiplicity of that? The multiplicity is a 1 because there was no exponent. Remember, odd multiplicity means it's going to cross. Okay. Here, again, you can set it equal to 0, or you can say x minus r. R is positive 2, right? X minus 2 equals 0. X is a positive 2. It has a multiplicity of 2 this time. So this one has a multiplicity of 2. This one has a multiplicity of 1. 2 is an even number. And so instead of crossing, it's going to touch the x-axis. Finally, what is our y-intercept? Remember, for your y-intercept, you multiply the constants. Here, the constant is 1, and here it is negative 2, but raised to the second power. So our y-intercept is negative 1. No, it's a positive 1, I apologize, times negative 2 to the second power. So again, we're not taking your real zeros. You're just looking at the equation itself. Anything that does not have an x, you're going to multiply together, okay? 1 and negative 2 squared just becomes 4, right? That means my y-intercept is at 0, 4. That is enough information to graph this situation. Good, shall we try? So we're saying 0, 4, 1/3, and 2, negative 1/3. All right, straightforward. Very bad at spacing these. All right. Our points are where x is 2, that means my first x-intercept is right here, right? It touches only, so it's going to come up or go down. Negative 1/3, I'll put that right here at the point negative 1/3, 0. It's going to cross. Good. And then 0, 4. It's going to cross, right? So we can say here it was just touching. Here it was crossing. Okay. And then you kind of check back to what you know. We know it was supposed to cross here, it does. We were supposed to touch here, it does. It's supposed to cross here, it does that. It has 2 or fewer turning points, 1, 2. That is true. And it should be going down to the left and up to the right. So it meets all of those criteria. So you now know when you see something like that, how to turn it into a graph. Isn't that amazing? All right, let's see how far we get on example A2. A2, 1B. Got ahead of myself, way ahead of myself. That was 1A. Now let's do 1B. 1B is f of x equals x plus 1 times x plus 3 squared times x minus 4. Good? All right. So what we want to find is the leading term. And you can go in whatever order you want. You don't have to do it this order. What is our leading term? It's going to be x times x squared times x, right? So it's just x to the 4th. If we compare that to our end behavior graphs, it's a positive x and an even exponent. So it's going to look like this. Good. So x to the 4th is going to be a parabola opening up. Is that okay? All right. So that was our leading term. We know it's going to open up in both directions, and that we have a degree 4. So our turning points will be less than or equal to 3, because 4 minus 1 is 3. Sound good? All right, let's talk about our real zeros or our x-intercepts, right? Where does it cross x? We have x plus 1, we have x plus 3 squared, and we have x minus 4. Good. Remember, it's x minus the real 0, or set it equal to 0. When you set it equal to 0, my real 0 is -1. Here my real 0 is -3, and here my real 0 is +4. I don't know, I hear it was like a bullet and then it became an equal sign. Consistency. Sound good? All right, let's talk about their multiplicity. -1 has a multiplicity of 1. That's an odd multiplicity. Think of an odd exponent. It's just going to cross, right? This has a multiplicity of 2. That's an even multiplicity, so it's going to touch the x-axis. And then this is, again, an odd multiplicity, so that's going to cross the x-axis. And that we decided by looking up here, right? 1, 2, 1. So it's going to resemble x to the power of 4. It's going to turn 3 times or fewer. It's going to cross at x is -1, touch at x is -3, and cross at x is +4. And then finally our y-intercept, right? Our y-intercept just means multiply our constants. The constants were 1, 3 squared, and -4, right? 1 times 3 squared times -4 gives me 1 times 9 times -4, which is -36. So the actual y-intercept is 0 on the x-axis, -36 on the y-axis. How much time do I have? Oh yeah, I still have 4 minutes. Oh, that was so fast. Yay. -36, all right. Again, we'll count by 5s. So I'm going to call this 0, -36. Good. Also going to cross So we're going to cross at -1. We're going to touch at -3. And we're going to cross at +4. Oh, sorry. Cross is like this. Touching is like this because I'm not sure whether we're going down or up, right? All right. From 0, -36, I like to start there because I know what I can do from there. It's not very beautiful. Okay, so if it was sharp like that, it probably means I'm going way, way down. We don't know where the bottom of it is. And then we come back up. Oh, either way, it makes us so bad looking. All right, so we crossed here, we crossed here. That means I do have to go down. So my arrow is going to be moving. No, that was a touch. That was a touch. I hate that. That's the ugliest thing I've ever drawn. All right, real quick. Here's -3. Here's -1. Here's 4. Here's -36. Let's try this again. I'm going to touch here. I'm going to cross here. Go down. Just going to go down forever. We don't know where. Come back up. Okay. That was very bad. All right. Does this follow this rule? It opens up on the left and the right. It has 3 or fewer turning points. 1, 2, 3. And it crosses at -36. It crosses at -3. It crosses at -1. And it crosses at +4. So as far as we know, this is okay. This is true. Sound good? I'm going to stop the recording.